So we're going to continue here discussing coterminal angles, and here's a couple of good exercises to see if you understand that idea. And so in exercise 22, given each angle, find an angle theta. So theta will be our answer. That's what we're looking for. Where 0 is less than theta is less than 360 degrees. So that means theta has to be an angle whose measure is between 0 and 360 that is coterminal to the given angle. So that we're looking for a theta that has two properties. Its measure is between 0 and 360, and it's coterminal to the angle that's given. So let's do part A here. So we're given 480 degrees. Now, what I have to do is I have to sketch this angle in standard position to be able to figure out what's going on here. So I'm going to take, now, I guess once you get the hang of it, you might not have to draw a sketch each time, but I'm going to draw a sketch here because we're just starting out on this idea. And I'm trying to draw, I know 480 is more than 360, so how much more? I think it's 120 more, right? So 480 is 360 plus 120 degrees. So if I'm going to draw 480 in standard position, I'm going to go around, and I kind of know 120 is more than 90 degrees. So there's 480 degrees in standard position. What we're trying to find is an angle that has the same terminal side and that lies between 0 and 360. Lying between 0 and 360 is kind of like saying it's positive and it's in that first rotation around the circle. All right, first rotation. So if I were to just draw here, I could just draw the angle we want. It's that one, all right, starting from the positive x, going in the positive direction to that terminal side. And I know what the answer is. Because of the way we calculated, how we figured out how to draw 480, we know we're 120 degrees beyond 360, so we know this angle has to be 120 degrees. So theta equals 120 degrees is the angle we want. It is coterminal to 480, and it's between 0 and 360. Let's do part B, 750. Same kind of idea now, right? I just got to subtract 360. And I don't have my calculator here, so I have to do this by hand. And notice I still have more than 360, so I could subtract 360 again. And I get 30, which means 750 is equal to 360 plus 360 plus 30. And the answer is staring at us already, but let's go ahead and draw 750 in standard position. So 750 is going to be one full circle, a second full circle. Two full circles is 360 and 360 is 720. So 750 is a little bit more, right? So there's 750 degrees. But the angle we want is this guy right there. So the angle that's between 0 and 360, coterminal, and we saw it from our calculation, that's 30 degrees. So theta equals 30 degrees is the coterminal angle that we're looking for. Part C, negative 45 degrees. Ooh, easy one to draw, not hard to draw, negative 45 degrees. Okay, now the conditions here are to there are infinitely many angles that are coterminal to this given angle. But it turns out there's only going to be one that's between 0 and 360. So saying we're between 0 and 360 says we have to rotate counterclockwise. We have to go this way, all the way around to that same terminal side. And so we want to be able to describe the angle I just indicated. And since it's coterminal with negative 45 degrees, I think you can see that if we just take 360 minus 45. So it's not hard to figure these out. There's no one formula that will always work for them. I think you just have to consider each case separately. And is that 315, 340, 50, 60? I think so. So this is 315 degrees. It's big, but it's less than 360. And so the angle theta we're looking for is 315. And we got it. Okay. Now I think we can, in the same segment, we can finish this up with one more exercise. It's a very similar kind of exercise, exercise 23. We're just going to work with radians here. So we're going to find, given each angle, we're going to find an angle theta where theta is between 0 and 2 pi radians. That means that is coterminal to the given angle. So exactly the same kind of process. It's just that we're going to work with radian measure. So it's a little harder to draw some of these pictures, right? So 17 pi over 6 is 17 times pi over 6. And in the back of my mind, I remember that pi over 6 is 30 degrees. So I'm thinking of those multiples of 30 degrees. Each quadrant has 3 copies of 30 degrees. So what is 17 pi over 6? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, full circle. 13, 14, 15, 16, 17. Pi over 6 is right here. There we go. And now my picture's a little bit sloppy, right? It would correspond to this terminal side here on my fancier picture. So what we want to figure out for our answer is just what's this angle in radians. And if you wanted to, you could convert to degrees and go back to radians, but I think we can get it from here. We can just count those multiples of pi over 6 again. 1, 2, 3, 4, 5. Can you see that's 5 pi over 6? Just like from this picture, we would have gone, oh, oops, sorry, that's my degree version. Let's look at the radian version. 1, 2, 3, 4, 5 pi over 6. 5 copies. 5 times 30 degrees. It's the same thing. So here the theta that we want is 5 pi over 6. And we know from the way we drew this that it's between 0 and 2 pi just because it's in that first rotation around the circle, right? Okay, that was pretty intense. Let's get negative 3 pi over 4. I like this because it's a negative multiple of pi over 4, which means we're looking at multiples of 45 degrees. So negative 3 pi over 4, negative 1, 2, 3 pi over 4 would be right down here. And what the angle we want is when we come around in a positive direction in the first rotation and hit that same spot. And again, if we want to refer to my fancy picture of the multiples of pi over 4, cutting each quadrant in half. And we count the axes here as we go around when you do multiples of pi over 4. So it's 1, 2, 3, 4, 5. 5 pi over 4. That's what we're looking for. Right, 5 copies of 45 degrees. So the theta we're looking for is 5 pi over 4. Coterminal to negative 3 pi over 4, and it lies between 0 and 2 pi in that first rotation. Negative 10 pi over 3, that's negative 10 times pi over 3. Pi over 3 is 60 degrees. 60 degrees is always a little trickier to work with, because it's like 60, 120, 180, the next multiple, the next multiple, the next multiple. So the multiples hit the x-axis but not the y. So when I count negative 10 pi over 3, negative 1, negative 2, negative 3 takes me to a straight angle. Negative 4, 5, 6 is full circle. 7, 8, 9. Negative 10 pi over 3 is right here. Okay. Where are my pi over 3 multiples? So my pi over 3 multiple picture, we're on this terminal side here. And so the angle we want going in the positive direction is that one. Again, from the well-drawn picture, it's not too hard to see. That's just going to be positive 1, 2 pi over 3. It's the same as 120 degrees. 2 pi over 3. That's the coterminal angle we're looking for in part C. And we are done with 7.1. So the next videos will jump to section 7.3.